So, good morning student, welcome to our subject mechanics of composite material. Now what is a composite? Although man-made composites have existed for thousands of years, the high technology of advanced composite has been used in the aerospace industry only for the last 30 years. What is a composite? A composite is a structural material which consists of combining two or more constituents. For example, in your human body, flesh in your leg reinforced with bones, concrete reinforced with steel, epoxy reinforced with graphite fiber. So, what is a composite material? It is a mixture of two or more constituent materials with significantly different physical or chemical property which remain separate and distinct on a macroscopic level within the finished structure. In other words, we can define the composite material is the combination of two or more materials with significantly different physical or chemical property which when combined together produces superior and enhanced property than the individual constituent material. So, in simple words, it is a combination of two or more material. Those materials should be different in physical and chemical property, which when combined it should give enhanced property than its constituent material. Now, composites in nature. See the sea cells. These are composites in nature. Abalone cell, calcium carbonate, is stronger than calcite, CaCO3. Wood is a good example of composite. It is a mixture of cellulose filament in a matrix with lignin and hemicellulose growth rings. This is oak wood, pine wood. These are fine example of composite material which are available in nature. Now, what is a composite material? If a material satisfies this following condition, it consists, as I told, it consists of two or more physically or chemically distinct, suitably arranged distributed phase. Second, it has the property that are different from either the parent material and should be enhanced than this parent material. Third, it should be manufactured. It's not a natural except this wood or bone. It should be manufactured. You should manufacture this with a mixture of two materials. Now, example of composite materials used in engineering: concrete, chipboard, fiber reinforced composite, etc. Composites which occur in nature would consist of strong flexible cellulose fibers surrounded and held together by a stiffer material called lignin. Bone is a composite of strong yet soft protein collagen with hard and brittle apatite. These are some example of wood. This is example of laminate wood. Now we will see what are the different phases. So as I told, it is a combination of two phases. So what are different phases? One phase will be matrix, or it is a binder, which is continuous in nature. It surrounds or binds together the fiber of other material, which are called reinforcement. These fibers or fragments, these are called reinforcement, or we call it dispersed phases. In some cases where, so this is an example of composite material. You see, these are of continuous phases. Here these are of matrix reinforcement. These are of these parts are matrix phases. So where this matrix and this reinforcement are mixed, these are called interface phases. The more interfacial strength it may exert, the composite will have very better, higher property. Now, why will prefer composite? First, it will give you a higher specific strength. It is a lightweight, design flexibility. You can design as per your own requirement. consolidation of parts, net safe manufacturing. Why we study? Many of our modern technology require materials with unusual combination of property that cannot be made by conventional metal alloys or ceramic or polymeric materials. For example, these monolithic materials, they may have given some experiment very good, excellent property, but while requirement of this modern day application, we require a combination of property with strength, mechanical strength, with tribological property, with a combination of mechanical or thermal property. So this composite will have an important function with providing a combination of varieties of property. Now, as I said, monolithic materials have concentrated in achieving good combination of properties such as strength, stiffness, wear resistance. They may have given strength, but if you see wear resistance, may have some limitation. So, by choosing an appropriate combination of matrix and reinforcement material, a new material can be made that exactly meets the requirements of a particular application. The biggest advantage of modern composite material is that they are light as well as strong. The specific strength is higher. Composites provide design flexibility because many of them can be molded into complex shapes. So complex shape manufacturing, if you see, we have our own flexibility to provide to manufacture composite material as per our own requirement. So here it comes the features of composite materials. As I told, good specific strength. The specific strength is the ratio of strength to unit weight. The composites developed have specific strength about 40 to 60% more than aluminium. See, aluminium has the lightest metal with high specific strength. If you provide a composite materials, taking itself as aluminium as a matrix, it will provide more at least 40 to 60% more specific strength. High specific stiffness. Composites can offer stiffness of steel at 1/5 of its weight and equal to stiffness of aluminium half of its weight. It can provide higher wear and corrosion resistance. Compared with metal, composites have higher corrosion resistance, which are very more chemically stable than metals. Long durability. Life of the composite material is higher than the conventional material. That's why a trade is saying where conventional materials are not preferred. Cost wise, right now it quite high, but when trends will become, when the composite materials will be used in all sets of industry, certainly the cost is going to be economical in near future. High specific modulus. Specific modulus can be defined as the ratio of Young's modulus and density. The specific modulus is high for composite material, which means the rod with cross section made of composites could only be 1/3 of steel of same strength. Similarly, good impact property like glass fiber, Kevlar fiber provides good impact property than steel and aluminium. This Kevlar fiber, they are very much used in our bulletproof jacket in defense application. Now we'll see what are different application of composite material. This is an example of this automobile. You see this various parts. These parts can be already replaced with composite materials. Aircrafts. You see this aircraft nowadays, this all part nearly more than 50% are made up of aluminium. In near future it's going to be more than 80%. For example, it is Airbus 380. Here is a example Airbus 380. Whatever you see, this wing ribs, section, tailplane, their nose, upper deck material, advanced cabin material, fuselage, all these materials are replaced with composite materials. You can see the vast usage of this composite material in the aircraft application. Similarly, a Boeing 787 Dreamliner, you see it's already the half of the materials are made up of composites. Definitely with the near future it will be going to more than 70 or 80% of the materials are made up of composite material. In space satellite application, due to its low weight with low thermal expansion characteristics of advanced composites, they are very much used to significant advantages in space satellite application. Defense industry, I said Kevlar fiber is high impact resistance. So composites are used to bulletproof jacket. The puffins used for this application are very tightly wounded, covered with resin so that they can absorb great amount of impact force hit by a bullet. Even they can resist with certain amount of bomb. Or blade or this sports cycle, these materials, these are made up of composite, polymer composite. Renewable energy, this windmills, parts of windmill, whatever this biomedical application, industrial spraying, all these are made up of some composite material. You see this honeycomb panel used in aircraft, it's a composite material. Natural composite, as I said, wood, bones are made of, are fine example of naturally available composite material. Now, the composite where at least two constituents material, one being a matrix phase, whereas other being a ceramic or organic compound, that is called reinforcement phase. The reinforcement phase is embedded into the matrix phase to make it as a whole as a composite material. Matrix phase is soft in nature. Flexible in nature, and is of continuous form, whereas the reinforcement phase is hard, stiff, and of discontinuous in nature. We will see what are the function of matrix. Matrix binds the fibers together and transfers the load to the fiber. It provides the loads to the fiber. The matrix provides the rigidity or the final shape or net shape to the structure. The matrix isolates the fiber so that individual fibers can act separately, which stops or slow the propagation of crack. It provides barrier against an adverse environment and protects the transfer of the fiber from chemical attack or mechanical damage such as wear, abrasion. The matrix provides a good surface finish quality and aids in production of net shape or near shape parts. Failure mode is highly affected by the types of matrix material and used in the composites as well as compatibility with fiber. So it shows the importance of the matrix material. Similarly, what are the function of reinforcement phase? It carries the load. 70 to 80% of the load is carried by the fiber. To provide enhanced stiffness, strength, thermal stability, and other structural property. To provide electrical conductivity or insulation depending upon the fiber usage or fiber used. We will see the geometric and physical definition which are associated with the composite material. Homogeneous material is one where properties are same at every point, or we can say these are independent of position or location in a body. Similarly, heterogeneity is the just opposite of the homogeneous material. It is dependent on the position of the body, where the property will vary from one position to another position. Similarly, what is isotropic material? Isotropic material is one where the property are same in all direction, or we can say it is independent of the orientation of the reinforcement axis. Anisotropy, where the property vary from one direction, or we can say it depends on the orientation of the reference axis. Another one term, what is lamina and what is a laminate? Lamina, it is also called as a ply or a layer. It is a single flat layer of unidirectional fibers or woven fibers arranged in a matrix. A laminate is a stack of plies of composite. Each layer can be laid at various orientation and can be made up of some different material system. So students, that's it for this session. See you in the next session.